Hey folks, Doug Blake with Body Design University. Welcome to another weekly study. And in today's video, we're going to talk about two concepts. You're going to find them on page 443. This is chapter 14, flexibility training concepts. And those two terms are known as altered reciprocal inhibition, and right below it, synergistic dominance. Now they could be a little bit challenging to understand, but I just want to kind of go over them real quick with you and just get it out of the way so you understand. And remember, there's two things you have to do. One is pass the exam, right? So just keep in mind that basic concepts in the human movement system, kinesiology, biomechanics, some of these basic concepts, you need to memorize them so you can do what? Pass that question, get that question correct, and then ultimately pass the exam and be done with it. Okay, that's kind of the goal here. In the quote real world of actually training people, you will probably never talk about these to anybody. I don't know any time that I've ever actually explained any of this to a client or even to another trainer, but the concepts are actually pretty important to know from an actual real world training perspective. Because again, when you're actually training people and you're on the fly and you're doing exercises, it's really very helpful to understand why particular problems are occurring with your client. If you understand something as basic as, for instance, synergistic dominance, you can actually look at a client and you can now see it almost pops out at you when you see their pelvis kind of tilted, posteriorly tilted, and they got that, that the butt tuck going. Well, that's actually caused by these two guys. All generally, I'm not saying that every cause of this postural distortion is caused by these two guys, but that's generally what you're going to see with the average apparently healthy person. So remember, the goal here is to understand the material. There's nothing wrong with actually memorizing this, getting it straight in your head so that when you see a question on the test, if you see questions about it, you'll be able to successfully navigate that question, get the answer, move on, and then pass the exam. Once you pass the exam, now you can get down to the business of actually learning how to train people, right? And so that's that other side of the coin. And so the goal here is to know the material, and then if it's something that is worth knowing or utilizing in the real world when you're training people, well, then so much the better. Remember what NASM has done for you in this textbook, and they've given you the definitions on the side. Keep in mind that as you're going through this video, highly recommended, put it on pause if you need to, go get your textbook. Remember the old adage, read, write, recite. Grab yourself some paper, pencil, you're going to draw, you'll write. Read, write, recite. And when I say read and then recite, that could be literally just rewriting the words and their definitions, which in this case is actually good because you want to know what the definition of altered reciprocal inhibition is. Now, you have to know what reciprocal inhibition is as well. And that's something that you should have basically memorized, and conceptually, it's not that difficult to understand. And you have it here on page 443 right at the top. There's your definition. This is what I recommend you do. So I'm just going to write reciprocal inhibition. And I'm going to say when an agonist receives a signal to contract, I might write that out, or I could summarize it if I wanted to. It's basically when the primary agonist is moving through its contraction. So if the bicep is shortening, going through a concentric contraction, then the antagonistic muscle around that joint, in this case, the tricep, what it's known as your functional antagonist, receives an inhibitory signal. This guy works, this guy doesn't. Simple as that. If that guy's working, this guy needs to take a break. That's what reciprocal inhibition is. It's a normal, not only normal, it has to happen for normal movement patterns to occur. Could you imagine if you're trying to curl a dumbbell and your tricep contracts at the same time, you'd be like this, right? Imagine if you were running, and by the way, in athletic events, some sprinters, they will pull a hamstring because there'll be a lapse in the neural control systems that tell the quadricep to relax while the hamstring contracts, right? Those are the agonist, antagonist. And so as soon as that heel strike goes down, the hamstrings go through a heavy loaded pull. And at that point, the quadriceps should technically relax, allowing the hamstring to go through its primary function of knee flexion and hip extension. If for just a millisecond those quads forget to relax, guess what happens? The hamstrings have to pull against a contracted antagonist, the quadriceps, and they always lose because the quads are much stronger, much more powerful than the hamstrings. You could get a hamstring pull. It does happen. I'm not saying it happens often. The point is that when the agonist is working, the antagonist needs to relax. And that's how muscle, human movement actually occurs smooth and controlled and efficiently. Okay, so that's reciprocal inhibition. Therefore, altered reciprocal inhibition, and you can read it here. Altered reciprocal inhibition means there's a problem. Reciprocal inhibition, normal, altered, there's a problem. And so all we're saying with altered reciprocal inhibition, and again, they have a decent explanation of it. And it's all based on whether the muscle, the agonist is overactive and the antagonist then becomes underactive. Remember, keep in mind that muscles are always under some neurological stimuli, always, unless you're paralyzed. But every single muscle on your body, right, is always under a slight level of what's known as tonus, right? Some sort of neurological stimulus. When that normal level of neurological stimulus is sort of up-regulated or there's more of it, so there's an increase in neural activity, that muscle, which is under a normal level of tension, gets tighter. Here's the interesting thing. It doesn't have to just shorten, right? It can actually just get tighter. And this imperceptible shortening of the muscle is enough to create an altered neural drive to the antagonistic muscle. Okay. So if my bicep, for instance, starts to get an increased neural drive to it, right? It becomes overactive. Altered reciprocal inhibition then actually forces the antagonistic muscle, the tricep, to become underactive. And then you can just kind of go through what the examples that they give. Overactive chest, right? Pectoralis major minor, decreasing neural drive to the mid-back muscles, i.e. the trapezius and the lower trapezius, lower trapezius, and the rhomboids. Overactive chest muscles cause the mid-back muscles to become underactive. You get the idea. You just don't let the terminology underactive, overactive throw you off. Don't let neural drive, some of these terms, throw you off. If you're not familiar with the parlance that is used in kinesiology, biomechanics, don't let that throw you off. Muscles that work against each other under normal conditions, and by the way, if you look at the picture on page 442, right, they give you a good example of what, this ideal of muscles that are balanced. And then if one is pulling too hard, it draws the other and lengthens it. The point is that all of your muscles are constantly under some level of tension, but it's a balanced tension. So when my arm is hanging to the side, there is a normal balanced level of tension between my biceps and my triceps over the elbow joint. Got it? Okay. Under normal conditions, my bicep has a certain level of tension that is perfectly balanced with the level of tension in my tricep. But if my tricep, for whatever reason, this is the kind of the point, is that whatever the reason is, if the neural drive, more nervous stimulus goes to the tricep, what happened to that? What happened to that nice balance? It's like a dance, right? So the biceps and triceps are dancing with each other, right? No one's leading, no one's following, but then the tricep takes over and he tries to lead the dance, so to speak. It's got more neurological activity. Altered reciprocal inhibition, because now that the tricep in this case is overactive, it has a greater level of neurological stimulus, is throwing off this fine balance. What happens is if the bicep, the antagonist in this case, is going to now start to receive a decreased neural drive, it becomes what? Underactive. And so don't let the memorization, by the way, don't let the memorization of the different muscles confuse you and throw you off with this. One of the best ways to memorize this material as you're going through it is to just simply look. And look, if you got to memorize some muscles, folks. You got to know certain, you don't have to know all 600 plus muscles. That's ridiculous. There's maybe 20, 25 muscles, 30 muscles, maybe. By the way, and that's from a testing perspective. In the real world, there's like 12 muscles. I don't know. I'd have to count it, right? There's your biceps, your triceps, your pecs, okay. There's not a lot of muscles to memorize, and those primary movers around the particular joints of your body, those are the ones you got to memorize. You just got to know what their kinesiological functions are. Then all you have to do at this point to understand this, right, is to know which ones work against each other. There's muscles on the front of your body that work against muscles in the back of your body, right? Most of you already know that your quads work opposite to the hamstrings. Quads are in the front, hamstrings in the back. Those are the things that make sense to memorize. Once that happens, then it's easy to answer a question that says an overactive gluteus maximus might be related to an underactive what? Well, now, wait a minute. If you don't know where the glutes are, well, they're in the back and they're hip extensors. You're not going to be able to answer the question if in the question there are predominant hip flexors, right? Because hip extensors do the opposite of hip extension. So if you had something like the iliacus or the psoas, well, there's your answer. But you have to know those. Those are the things you have to memorize. Not difficult to memorize. Read, write, recite. Say it over in your head. And again, I've gone through a number of videos to help you in those particular areas. But remember, altered reciprocal inhibition. This is from a faulty neural drive scenario. Remember and read it. 443, reciprocal inhibition naturally occurring. That's normal. Altered reciprocal is the impairment of the human movement system. Okay. And NASM says you should aim to correct it. Well, of course, but don't worry about in the real world trying to correct this with all these different. It's really simple. You stretch the overactive, and NASM will say foam roll. Okay. Foam, by the way, foam rolling is great. I usually use like a ball, but I use a foam roller as well. That's going to inhibit the neural drive to whatever the muscle is that you're squeezing, right? And they're going to say foam roll, stretch. And then it's caused by an overactive, and there it is, overactive agonist muscle. Don't confuse agonist and antagonist. An overactive agonist, whatever, remember, your bicep is not the agonist every time you work out. It's only the agonist when it's the agonist and you're doing a dumbbell curl. But what is the functional antagonist of the bicep becomes the agonist when you're doing push downs, right? Because now the tricep is the muscle you're working. So don't confuse these two. The term agonist and antagonist, it's a moving target. One during one exercise, right? During a curl, what's the agonist? The biceps muscles, right? What's the antagonist in a bicep curl? That's why you've got to define what it is you're talking about. The antagonist is the tricep. Okay, you got that. Agonist, antagonist. But I'm done with dumbbell curls, and now I go over and I do tricep push downs on the cable machine. You tell me what just happened. Well, the bicep now just went from being the agonist during a dumbbell curl to now it's the antagonist because the tricep is the primary muscle that we're working. So it becomes the agonist. And so you got to understand movement patterns and and what muscles are doing during those movement patterns. That's why altered reciprocal inhibition is a very important concept to understand in the real world. Now, honestly, most of what you're seeing here, the explanations of these is really going to be related more to kind of postural issues that people face. But the reason this is in the flexibility chapter is because it is targeted. We target overactive muscles. We target underactive muscles, and we target the overactive muscles specifically during this flexibility type of training. That's why the concepts are being spoken about here in chapter 14. So the point is that altered reciprocal inhibition simply relates to overactive muscles causing an increased underactive nature to underactive component in the antagonist. Or it's probably easier to say that an overactive muscle decreases the neural drive to the functional antagonist. And that's pretty much as simple as it gets with altered reciprocal inhibition. And what NASM will tell you at the very end here in this one paragraph is that here is the real world nature of this. Altered reciprocal inhibition changes the force couple relationship. I just spoke about force coupling relationship in a previous video that I did last week. It produces synergistic dominance, which is what? That's what we're going to talk about next, and leads to the development of faulty movement patterns. Okay, the way I used to deal with it many years ago when I would deal with athletes in particular is if they were having struggles with their ability to throw the ball properly, or if they had an injury, they were a mess. In other words, what would be normal, efficient movement patterns due to, in this case, well, in some cases, altered reciprocal inhibition, could be due to other things, would lead to these faulty movement patterns. And you can see this is really, once you start to delve into this, go onto YouTube and look at the videos of high level athletes, for instance, that get injuries. And you can see, if you can see, get movements. It's really cool to watch some of these movement patterns in slow motion. I used to do studies when I was going through college back in the 80s. I did swim analyses on high level swimmers, and you can do slow motion analyses of velocity and acceleration on their hand movements. It's really very interesting, but you can see where altered movement patterns were occurring, right? And so you could see where a normal pull, just for instance, pulling back this way, you would be able to see their shoulder, just as a for instance, lift up. You see, you don't even notice that, right? Because when it's moving really fast, like someone's doing a pull, you don't even notice that. But if you slow it down, there's your altered reciprocal inhibition, synergistic dominance, whatever the case is. You can pinpoint it, and that gives you the ability then to target those particular muscles, foam roll the traps, do whatever you got to do to help an individual with that. Synergistic dominance is the next one. Hope that explains altered reciprocal inhibition in an effective way. Synergistic dominance, but those words are just too complicated anyway. So synergistic, you got to know what a synergist is. Now, here's something just to keep in mind from a testing perspective. NASM wants you to understand that every kinesiological function, whether it's elbow flexion, knee extension, hip flexion, hip extension, dorsiflexion, whatever, has a primary mover and then has helpers, or what are known as synergists. Now, don't tell anybody. That's not actually correct. You could call a muscle a prime mover simply because pretty much every joint in your body, right? Every kinesiological function in general, I'd have to think really hard of a joint. I'm trying to think. I can't think of any joint in the body that only has one muscle that provides that particular kinesiological function. And remember, when I say kinesiological function, I'm talking about the words flexion, extension, abduction, adduction, right? Those terms that you've already gone through. Every joint in your body has at least two or more muscles that help move that particular joint through that particular kinesiological function. Give you an example. Elbow flexion is not the biceps. Elbow flexion has three main muscles that are always active, always. Now, yes, positioning of the elbow changes how much percent of load is being taken up by one of those three main muscles. Okay, biceps brachii, right, which is the that's what we call the bicep, the brachialis underneath, and the brachioradialis. It doesn't matter what you train. It doesn't matter if you do dumbbell, if you do hammer curls, standard curls, reverse curls. Those three muscles all work together. They're always working. You cannot do a curl, you cannot flex the elbow under load without contracting the brachioradialis. You have to. Okay, that's just the way it works. The question is which one is the dominant one, right? And it depends on the position, supination, pronation of the wrist. Right? Who cares? But the point is that when we talk about synergist, the point is that all the muscles that provide a particular kinesiological function are synergistic. Take a look at hip flexion. Perfect example of this. When your body is flexing the hip, when you are flexing your hip, what are all the muscles involved in hip flexion? And can you really define that one of them is the primary? I guess you could if you looked at total percentage of load being accepted by that muscle. Point is that every muscle involved with hip flexion are synergistic with each other. What NASM wants you to understand is that you have to pick one. You got to pick one muscle as the primary, and therefore all the other muscles that are involved with that kinesiological function are technically synergists. Okay, so if we're talking about hip flexion, just as a for instance, the most powerful, some of the really most powerful muscles in your body are the iliac and psoas. Okay, and we call that the ilio-psoas complex because they really are almost indistinguishable when it comes to that kinesiological function. However, your rectus femoris, which is one of your quadricep muscles, is a very powerful hip flexor, but only at specific times. I'll give you a great example. You can try this. Actually, you can put me on pause if you want. But do this. I want you to get on the ground, and I want you to try to do a sit-up. You're going to do a sit-up two ways. One, you're going to do the sit-up with your legs straight out. And then the other way, you're going to do your sit-up with your legs bent, with your knees bent. Which one do you think is easier to perform? Right? Just think about it for a second, and you can try it. Yes, the ones with the knees bent. Why? And it has nothing to do with the hip. Okay, it has nothing to do with the proximal insertion of the quadricep. It has to do with the distal insertion over the knee. The rectus femoris works over the knee, it works over the hips. When you bend the knee, you lengthen the quadricep. And once you lengthen the quadricep, you actually put it in a better, more efficient line of pull because it's lengthened, its length tension relationship is going to be better, stronger when the knee is bent and you have lengthened it. But as soon as you straighten your leg out, you shorten the muscle. And what we know, double jointed muscles for sure, but all muscles in general, when they are shortened, they lose their overall power output because of the length tension relationship. Okay, so you try it. You try doing a sit-up with your legs straight out. It's going to be whoa, and you're going to feel probably in your back. Bend the knees. You can do it. Point is that synergistic dominance basically says that, well, if let's just say we're saying that the ilio-psoas or the iliacus and psoas combo are your primary hip flexors. Okay, let's say they are the primary. Well, what are the other muscles that are involved in hip flexion? Well, you've got the rectus femoris, like I was saying, which is, right in there with, being called the primary. Your, believe it or not, your adductor complex actually helps and assists with hip flexion. Your TFL, your tensor fascia lata, is also, but see, now we can see that those guys like the TFL, they're too small. They are not going to be a primary. They are definitely going to be synergistic. So what then is synergistic dominance? Imagine that there's a problem with your ilio-psoas complex, right? Let's just say for whatever reason your psoas muscle is injured or something, whatever the cause is, it simply is not able to function at its highest level of efficiency. Well, I'm still going to do hip flexion, but then what has to happen? Well, this is where the other guys come in and try to help out. The problem is that, and by the way, they give helpful hint here at the bottom of page 443. Read through that. I mean, it's a great example. Basketball team, right? You got 5 or 6, whatever guys on the field. You got your point man. Now they say Michael. Let's say Michael Jordan. He's the best. He is. He gets hurt, he gets injured. Maybe he can still play a little bit, but he's no longer the dominant player. So the other guys got to come in and help out. Well, the fact of the matter is that the other guys are just not as good as he is. So you're going to lose some level of function. Doesn't mean you can't still play the game, right? It just means that your top player is no longer functioning at the highest capacity. We see this with the hip extensors, where the gluteus maximus is generally considered to be the primary mover of all the muscles involved with hip extension. So the hamstrings, for instance, again, these are sort of the classic examples that you'll get when you go through the NASM textbook. Why? Because we know that although there are other muscles involved, so for instance, the sartorius muscle for hip flexion, yes, it is involved with hip flexion. Now, it's actually more involved with external rotation, but it depends on the level of flex or the angle of flexion at the hip. But the point is that it is a quote, a hip flexor, but it is a synergist. At best, it's a synergist. And so that's kind of the point, is that if the sartorius muscle, great example, let's just say the sartorius muscle starts to get too much involved with hip flexion, it's just not designed to be to act in more of a primary role. It'll actually start to pull and externally rotate. And we see lots of injuries occur because of this. Okay. So the point is that synergistic dominance, just as a perfect example, is a issue that you would definitely want to kind of pinpoint with your clients when you're actually training them. This is where proper training technique really comes in. And this is also why stretching is not just something that makes you feel good. You got to get those overactive muscles. You got to stretch them, foam roll them, massage them. You got to do whatever you can to get them to sort of release, right? And limit their neural drive. And then do what? Strengthen the underactive guys. I'm just repeating what you're going to see throughout the NASM textbook itself. Altered reciprocal inhibition, synergistic dominance, critical concepts. Please, if you like these videos, go ahead and subscribe, hit the bell so you can get notifications when new content does come out. Look, our goal here at Body Design University is to help you pass this exam on the first shot. Now, if it's not your first time taking it, then the second or whatever you're on. But please keep in mind, what we do here at BDU is help you to understand not just the material and how to study it, but what type of learner are you? Because you can be told to just know this, this, and this, but remember, knowing it comes down to memorization. How are you going to memorize the material? Okay, so that you can do well on the test. Okay, that is the key. You got to know what your learning style is or how to study. If you don't know how to study, then put that as a comment in this video. Of course, go to our Facebook page, the largest study group on Facebook, the private NASM prep. Go there and post these questions about how to study, because remember, if you're frustrated, we get this all the time. You look at this book and you go, I got to memorize all of this. Well, I mean, that would be cool to pass the exam. It's not going to help you be a good trainer, but at least it'll help you to pass the exam. But know what your learning style is. Know how to study. That's where you go into the comments and let us know how we can assist you. Remember, pass on the first time or the second or wherever you are at, and just let us know how we can be of assistance. Remember, Body Design University, we also want you to learn how to be the best industry leading trainer. And you can just ask us how to do that. We'll be more than happy to give you some information. We will see you next week. It's always a pleasure. Take care.